Okay, question number 1a. We need to use standard results from the list of formulae MF19 to find the sum of 3r squared plus 3r plus 1 in terms of n, with r going from 1 to n, simplifying your answer. Now from MF19, this is what we have, and therefore if we were to find the sum of this, we can split this expression here. So 3 sum of r squared plus 3 sum of r, and then plus sum of 1. And therefore, now what we're going to do is, we're going to say 3 into sum of r squared is all of that. So 1 over 6n into n plus 1 times 2n plus 1, plus then 3 into sum of r is going to be half n into n plus 1. And of course, the sum of 1 means basically n. Right, so the 3n can go here, and I have then n into, if I were to expand this, okay, I'm going to get n into 2n squared plus 3n plus 1 over 2, and expanding over here, I'm going to get 3 into n squared plus 3n, and all of that divided by 2 plus the n. So simplifying further, I get 2n times n squared is 2n to the cube plus 3n to the square plus n, the same denominator over here, plus then 3n to the square, okay, plus 3n, plus, if I were to put this over 2, it's going to become 2n over 2. So then I can take all of that and divide it by 2. So 2n to the cube plus 6n to the square plus 3n plus 2n plus n is plus 3n. So 2 plus 3 is 5 plus 1 is 6. So I got then 6n. All right, so we have 6n, all of that divided by 2. So now from here, we're going to get the whole expression divided by 2. So that's going to become n to the cube plus 6n squared. So 6n squared divided by 2 is going to be equal to 3n to the square plus then 3n. So that's the first part of the question. So for part B of the question, I need to show that 1 over r cubed minus 1 over r plus 1 to the cube is equal to all of that. So what we're going to do, we're just going to cross multiply this, and what we can do is 1 over r cubed minus 1 over r plus 1 to the cube. Okay, I'm taking the left hand side of here, is going to be equal to r plus 1 to the cube. All right, so minus r to the cube, and then all of that divided by r to the cube into r plus 1 to the cube. Now, you can use the binomial expansion to expand this expression over here, and this is going to turn out to be r to the cube plus 3r to the square plus 3r minus r to the cube, and of course divided by r to the cube into r plus 1, all of that to the cube. So if we were to simplify this further, we are going to end up with the r cube, and the r cube takes away, it goes away. So we have 3r squared, okay, plus 3r plus also plus 1, right? But when you expand this, this is 1 here, 1 to the cube. All right, so we're left with then 3r squared plus 3r plus 1, and all of that being divided by r to the cube into r plus 1 to the cube. Now that's one part of the question here. And of course, now what we have to do is to use method of differences to find the sum of all of that. Now remember, this is exactly the same as this. So what we have then, I'm going to substitute the r for n. So I can say 1 over n to the cube minus 1 over n plus 1, all of that to the cube. Now if I were to do so, I'm going to take some values there, and because we can start with r is equal to 1, so I'm going to say basically when r, or when n is equal to 1, so what I have is 1 over 1 to the cube minus 1 over 1 plus 1 is 2 to the cube. Okay, then plus when n is equal to 2, all right, so 2 to the cube, so 1 over 2 to the cube, okay, minus 1 over 2 plus 1 is 3, so we got then 3 to the cube. So this is going to go on forever until we reach somewhere. Let's say here, if I say n minus 1, so I'm going to get 1 over n minus 1 to the cube, okay, minus 1 over n minus 1 plus 1 is n to the cube, because the next sequence is obtained by adding on 1 to it. So, and finally we have then plus this expression itself would say 1 over n to the cube, all right, okay, minus 1 over n plus 1, okay, to the cube. Now, let us see where we go with this. This doesn't get cancelled, so this one here is basically 1. And you can see this is going to cancel with that, and 1 over 3 to the cube is going to cancel with the next one, okay, because we're going to get 1 over 3 to the cube in the next stage. And of course, this is going to cancel out with the previous one, and this one is going to cancel out with this, okay. So finally, we're left with 1 and this one here. So then the sum of all that expression here, all right, 3r squared plus 3r plus 1 divided by r cube into r plus 1 to the cube is nothing more than just 1, okay, plus and minus becomes minus 1 over n plus 1 to the cube. So that's my answer to this part of the question. And the next part of the question, we need to deduce the value of this summation here with arguing from 1 to infinity. Now, because we know that this is the same as 1 minus 1 over n plus 1 to the cube. Now, over here in the denominator, as n approaches infinity, so 1 over n plus 1 to the cube is going to become 0. So the final deduction is that the final deduced value is 1. So this is the answer to the part C of the question. Okay, take care.